All right, so this is going to be topic 6.1, simplifying radicals. All right, and we're going to skip this warm up perfect squares and perfect cubes because I just gave you guys, I think I have it on here. Yeah, I just gave you guys this list. And so underneath the x squared, those are going to be all the perfect squares through 25 squared. And then all the perfect cubes, all the perfect fourths. We probably aren't going to do fifths in here, but you have those just in case. Um, so as far as like perfect fourths, you're probably not going to go down this slow, but that's okay. You'll have it just in case. So if you needed to know what the fourth root of 1,296 is, you just go over and it's going to be 6. That's how you can use that list in just a second. So on that warm up, everything's a little delayed. On that warm up, we can just say see the chart. Okay. So before we have done all the things we're going to do today, I think, with square roots. So now we're going to do them. We're still going to do square roots, but we'll also do cube roots and fourth roots. So the definition of a root. So if x is the nth root of a real number, if x to the nth is equal to a. Right? So if we wanted to find the square roots of 81, we would think like, what do you square to get 81? What do you think? 9. And there's actually another number you can square and get 81. It'd be negative 9. So 9 and negative 9 are square roots of 81 because 9 squared is 81 and negative 9 squared is 81. All right. So to find the cube root of negative 8, you would try to think, what raised to the third power gives you negative 8? What do you guys think? What to the third power gives you positive 8? It'd just be 2, yeah. So if we want to get negative 8, it's going to be negative 2. All right, because a negative times negative times negative will give you a negative. All right, and then the fourth root, this one you might not be able to do in your head. So if we're going to do the fourth root of 256, you would look under the x to the fourth. 256 is here, so the fourth root is going to be 4. But because it's an even root, it's also going to be negative 4. So 4 raised to the fourth is 256, and negative 4 raised to the fourth is 256. All right. So we are going to talk about the parts of a radical next. So this part here, it tells you the type of root that you're taking. That's called the index. All right. This symbol is called the radical sign. Let's call it the radical symbol. I don't know. It doesn't matter. And the number under the radical is called the radicand. What if you don't have a number right here? What if that's missing? What would the index be? Like, what? It'd be 2, yeah, because it's the square root. So if you just have that symbol with no index, no number there, it means the square root. Okay, we're not going to do this whole table. We're going to leave this part off. All right, so if we take the even root, like the square root or the fourth root of a positive number, that's going to give us a positive answer. If we take an odd root, like the cube root of a positive number, that's going to give us a positive answer. If I take the odd root, like the cube root of a negative, that's going to give us a negative answer. What about the even root of a negative, like the square root of -9? Do y'all remember what that is? It's going to be imaginary. Now that is not going to come up today, but I just want to review that. All right. And so whenever it is an even root, to do the positive or negative, if there's nothing in front of it, they want the positive answer. If there's a negative in front of it, they want the negative answer. All right, so we're going to do some of these together, starting with the square root of 289. Now that's probably not one you have memorized, but 289 is in the list of perfect squares, and the square root is going to be 17. All right, and then we have some fractions, and don't let the fractions scare you. It's not a big deal. So if there's a negative in front, we'll just go ahead and make it negative. And then to do the square root of a fraction, you just do the square root of the top. So what's the square root of 4? 2. And then just do the square root of the bottom. The square root of 25 is just 5. And that's all you have to do. It's not a big deal. All right. Then we're going to skip over and we're going to do the cube root of 8. Not yet. You guys are going to do this for your assignment. All right, so the cube root of 8. If you look at your perfect cube list, 8 is in it. These are the cubes. There's 8. So the cube root of 8 is just 2. All right. And then we're going to skip one and do the cube root of negative 125. So when it's a cube root of a negative, your answer is going to be negative. What do you guys think? Look in your perfect cube list. Good. All right, and then we're going to do these very last two. Now, 4096 is not something I have memorized for sure, but these are the fourth roots. So if I look in the fourth root column, try to zoom out a little bit. Yeah, here it is. So the fourth root is going to be 8, and then this one had a negative in the front, so it's going to be negative 8. Right. And then for this fraction, same thing. We don't worry about it. We just do, look in the fourth root column for 81. It's going to be a 3 on the top. And then the fourth root column for 16 is going to be 2. Good job. Okay, so they do get harder than this, just like they did before. You're going to have numbers that are not perfect squares or perfect cubes, and we have to break them down. So we're going to do some of those together. So on the back, we're going to do the evens together, and the odds are going to be your assignment. All right. So if you guys remember, when there was a number in the front, we just kind of kept it in the front, and then we're going to break 320 down. So what we want to do is find a perfect cube that divides evenly into 320. Not perfect cube, sorry. Perfect square. All right, so I am just looking at the perfect square column. I'm not looking at anything else. Let me get a calculator. So we're just going to take 320 and we're going to start dividing it by perfect squares. And I don't want to start at the top of the list. I want to kind of start in the middle. So if I was just guessing, I know what it is because I did this already. If I was just guessing, I would probably start with 121. And it doesn't work. So then I would go up. I know it's not 100 because 100 only divides into numbers that have at least 2 zeros. So then we would try 81. And it doesn't work. So we would try 64. And it divides evenly. So then I would break it down into the square root of 64 times the square root of 5. All right, and then from your chart or your brain or your calculator, it doesn't matter, you can see that the square root of 64 is 8. And then when you take the square root, if you guys remember, it breaks out of the radical prison, and then you just multiply everything that's on the outside together and leave the 5 on the inside. So ones like that we've done, maybe not with a number as big as 320, but we've definitely done that before. But I don't think we've done these with cube roots, but it's the same process. We're still going to break this down, but because it's cube root, we would do cube root times cube root. And then when we look at the list, we would need to make sure we're looking at the perfect cube list. I messed this up like 3 times in my 4th periods. So these are the numbers we're looking to see if they divide evenly into 108. If it was me, I would probably start with 64. And it doesn't work. Let's go to the next smaller one, which was 27. And it divides evenly. Okay, so it's going to be the cube root of 27 times the cube root of 4. And you can look from your table or your calculator. The cube root of 27 is just 3. So you get 9 cube root of 4. All right, now the next one, I'm going to change the problem just because I don't like the way it is. So let's change that to the square root of negative 24. Okay, so same thing. That 6 is just going to hang out. We're going to do a cube root times a cube root. Now when you have the cube root of a negative, if it was me, I would go ahead and make that first one negative. And then we want to find a perfect cube that divides evenly into 24. And there's really only one it could possibly be because 27 is bigger than 24 and 1 doesn't really count. So it's definitely going to be 8. (24) is 8 times 3. All right, and then the cube root of negative 8 is negative 2. Oh, sorry, it's 8. Oh, that's right. Sorry. I'm a little distracted today. All right, and then 8 times negative 2 is negative 12. All right. And then number 8 is a 4th root, which is probably the first time you've seen a lot with 4th roots. So we want to find a perfect 4th that divides evenly into 2,592. And I can go ahead and tell you it's going to be this number right here. And the fourth root of it is going to be 6. So that's going to be 1,296 times 2. And the fourth root of that number is 6. So it's going to be 30 times the fourth root of 2. Okay. So it's like what we've done before, just on like a larger scale. And it's been a while since we've done that for sure. Now, the newest part of today's lesson is doing all this breaking down when it's variables. I don't think we've done that this year. Now, we have talked about perfect squares, I think, with x's, but for a variable to be a perfect square, the exponent must be a multiple of 2. Cube root must be a multiple of 3. And fourth root must be a multiple of 4. So over to the side, I'm going to make some lists of variables that are perfect squares, cubes, and fourths. All right. So any variable, so x, y, a, b, c, whatever, that has an exponent that's even is a perfect square. So I'm just going to write it with the x's, but this works for any letter, any variable. And it keeps going on and on. If we want to find the square root, you're going to divide the exponent by 2. All right. You want to write this list. This list is going to be helpful in just a second. All right. For variables that are perfect cubes, all of the exponents need to be multiples of 3. So like x to the third, x to the 6th, x to the 9th, and to the 12th. What do you think you divide by to find the cube root of a variable? 3. And then perfect fourths is going to be multiples of 4. So x to the 4th, 8th, 12th, 16th. And then if I want to find the fourth root, I'm going to divide by 4. Okay, so we are going to do really the same thing with variables that we just did with numbers. So when I'm going to find the square root of this, I'm going to break it down into 2 square roots. Oh, sorry. Which one? All of them? All right, so we're going to start with the numbers first. So 324, since this is the square root, when I look at my list, 324 is in the list. So that's good. That's going to make this one not as hard as it has to be. So I'll just write it in my first square root. All right. And then a to the third. A to the third is not a perfect square. So what I'm going to do is I'm going to look at a list of my perfect squares. And I'm going to use these powers with a. So I want to get as close as a to the third as possible, but I can't go over. So it's going to be a to the second. All right. So that's going to go in this one. But I need this to equal a to the third. So how many more a's do I need to get a to the third? I need one more a. So I put that a right there. All right, this is confusing. It's going to take a little while for you guys for it to sink in. All right, then I'm going to do the same thing with the b's. So since this is a square root, I'm going to look at my perfect square variables. I want to get as close to the 7th without going over. What do y'all think? Close to the 7th without going over? It's going to be the 6th. So we'll do b to the 6th here. And then how many more b's do we need? One more b to get 7. All right. And then just like I did on 2 through 8, this first one, these are all perfect squares. So I'm going to find the square root. So the square root of 327, was that 17? Can't remember. Oh, look. 18? I don't have it memorized. 18. So that's just going to be 18. And then when I do the square root of the variables, I'm just dividing the exponents by 2. So it'll be a to the first, b to the third, and then this other one just stays underneath. Right? That's a lot. And it might take a minute for it to all sink in. All right, we're going to do the same thing on this one. So it's cube roots. So I'm going to do 2 cube roots. I need to find a perfect cube that divides evenly into 56, because 56 is not in my perfect cube list. So that's going to be 8. So 56 is 8 times 7. Right? And then for my S and my R, I'm going to look, I have R to the 8th. So I'm going to look in my cubes. I want to get as close to the 8th power without going over. So that's going to be the 6th power. So R to the 6th. How many more R's do I need to get 8? 2 more R's. So those 2 go in the second one. Okay. Then we have S to the 4th. I want to get as close to 4 without going over. That's going to be the 3rd. And then I need one more S to get S to the 4th. Okay. And then the cube root of 8 is just 2. And then for these, we're dividing. You divide 6 by 3. That's R to the 2nd. Divide 3 by 3. That's S to the 1st. And then this other stuff just stays underneath. Right? Does that kind of make sense? That's kind of weird. Okay, we're going to do a couple more. All right, so this next one has cube roots. So we'll do 2 cube roots. Now, when I see a negative here, I'm just going to go ahead and make my first one negative. All right, and then I need to find a perfect cube that divides evenly into 81. All right, so that's going to be 27. 81 is 27 times 3. All right, and then this one is kind of tricky. So we have this p to the 2nd, and this is a cube root. So if I'm looking at these cubes, I can't go to a number without going over 2. So if this number is smaller than this one, then I can't break it down. So you just put it over in the second radical. All right. And then q to the 12th for perfect cubes. 12 is a perfect, the power of 12 is a perfect cube, so I can just leave it as q to the 12th. So I'll do the cube root and then divide, and then I'll leave the other one like it is. And then the last one we're going to do together is 16. And it's the fourth root. So we do a fourth root times a fourth root. All right, so we're going to look at the fourth root column. And 48 is the number. There's only one number that could possibly work, and it's 16 because 1 doesn't really count. 81 is too big. And 16 does divide evenly into 48. 48 is 16 times 3. All right, and then if we look at m to the 8th, under the perfect fours, the 8th power is a perfect 4. So we'll go ahead and put it in our first one. And then n cubed is too small to break down, so it's just going to go over here. All right, and then we'll just do the fourth root, 2, and then divide, and it's m squared. And then the other stuff stays underneath. All right, so what questions do you guys have? Yes, sir.
How do you know what you get? How do you got 2 and
Okay, so this 2?
Yeah.
That's the fourth root of 16. So the fourth root of 16 is 2. You know how I got the other 2? The squared? Do you know how I got that one? Then for the variable, you divide. 8 divided by 4 is 2. All right. So what I want you guys to do, on the front page, there were a few of these ones that were a little easier to do. You can just do those looking at the chart, I think. And then the odds on the back. Yes, ma'am. Oh, I gotcha. There you go.
I have a question. How do you know the 1 is 117 on the square?
You find a square that divides evenly. There's one. It's a small one that goes into 117.